Hi friends, this is Anil here. Welcome to my YouTube channel Shreyas Data Insights. So in last session now we understood what is a big data problem, right? So we're talking about storage as well as processing. In today's session we'll understand what exactly Hadoop and how Hadoop resolves the big data issues. Right. So coming to this, basically Hadoop is an open source project which is written completely in Java. So Java is the native language for Hadoop. Okay, so having more compatibility with Java libraries and everything, right? For example, Spark, if you're talking about Spark, Scala is the native language for Spark. So even though you can program in Spark with a Python or R, but still Scala is having good compatibility. Why? Because Scala is a native language, having more libraries, more packages support. In a similar fashion, Java is the native language for Hadoop here. And this Hadoop is good to handle really massive amounts of data through parallelism. So it purely works on the distributed environment. So we are distributing the data to multiple nodes, right? And we are processing the data using parallel mechanism, right? So a variety of data. So Hadoop is not at all restricting you. Like I only process structured data, unstructured data, or a kind of semi-structured data. You can provide any kind of data based on your business. So Hadoop is able to process such data here without any hesitation. At the same time, uses inexpensive commodity hardware. What do you mean by that commodity hardware? So Hadoop is not at all demanding any high level, supercomputers or blade servers kind of thing. So with the existing, economic wise, with the existing nodes itself, we can make a cluster and we can distribute the data and we can process the data. I'm giving a simple scenario. If you're having 5 laptops with you or 3 laptops with you, right, you can just build your Hadoop cluster. That's it. Very simple thing here. And coming to the reliability, so the reliability provided through replication. Why? First of all, we are having some issues with the reliability. So once you are using this commodity hardware, we cannot issue the data to data existence. I mean to say, there is a chance to lose of data here. That's the reason when you're talking about the reliability, it will be provided with the help of replication. So by default, the replication is 3. So what do you mean by that really? So whenever you are copying your data from your local file system to Hadoop for processing purpose, 3 copies will be created by default. So for example, you are having an employee file with you. So you're copying that employee file from your local file system to Hadoop. Then what happens? 3 files will be created for that. So by default, that is 3, and it's a configurable parameter. In future, based on your requirement, you can make 2 copies or 1 replicant or 10 replicants also. But default is 3. And minimum replicants you can have 1. You cannot make that as a 0. Minimum replication is 1 here. At the same time, files are immutable. So what do you mean by that immutability? So once you have copied the data to Hadoop, you cannot update that. So no DML can possible, right? So for example, you're having some employee records in your Hadoop system, and you want to change a particular employee salary from 10,000 to 20,000. That is not possible. So you cannot update the records. Even you cannot create a file also. So you cannot create a file at Hadoop level. Only thing is you can just copy the data to Hadoop and you can start analyzing the data. Nothing but you can process the data, because Hadoop implemented a principle like write once, read many times. So you just copy your data and do number of analysis on the data. So those updates are not possible, but appending is possible. You cannot update the file, but appending is possible here. So practical, I'll be show all those things. Right. So as Hadoop is providing a distributed environment, it really helps us storing as well as processing also. So Hadoop providing here 2 things, not only storing but as well as processing also, and it follows master and slave architecture. So you're having some master nodes and you're having some slave nodes or worker nodes. Okay, in my next session anyway we will be discussing about architecture. That time you will be understanding very clearly. So what is a master and what is a slave, or what is a worker machine, how they will communicate, how they coordinate. Okay, what's the purpose of each node. So we'll identify each and everything there. But to limit the discussion here, Hadoop follows a distributed environment, and it follows a master and slave architecture where you can place your data. So some nodes are working as a master and some nodes are working as a worker machines or the slave machines. And coming to the latest version, 3.2.1 is the latest version. But remember guys, latest version doesn't give any specific reason to install. So it purely depends on the stable version. So enterprise look for the stable version, not for the latest release. Okay, so stable versions, we have to go and download the stable version, and we need to read the documentation. If you come across any issues, okay, so you need to read the documentation whether those issues really answered or not in this latest version. So based on that, you need to go and install Hadoop libraries. Okay, right. Now coming to the blocks. So first of all, we'll understand what you mean by block here. So as I discussed earlier, Hadoop is a distributed environment, right? So file system, here we are having a HDFS, nothing but Hadoop distributed file system. What do you mean by that? HDFS, Hadoop distributed file system. So it came from the concept called Google file system. So initially we are having a concept called Google file system. So from that Google file system, Hadoop implemented a file system called Hadoop distributed file system. In this particular file system, we are having blocks. So the file system is divided into chunks or the blocks here. So by default in generation 2, we are having 128 MB. So similar fashion, if you are working with the generation 1 architecture, so default blocks is a 64 MB. So Hadoop mainly deals with the two generations, generation 1 and generation 2. So we'll discuss these two architectures, okay, in our next session. What do you mean by generation 1, and what is the merits and what is the demerits, and why we enter into the second generation. Really all companies are using only generation 1 or only generation 2. So we'll understand and we'll discuss all those points in our next session. So limit to the discussion here. You need to understand here, Hadoop file system is going to divide it into number of blocks here. So the block size will be 64 MB by default in generation 1, and 128 MB, very bigger block, right? 128 MB block in generation 2. So it's a, I said, like, it's a default block size. So once again, it's a configurable parameter. If you want to increase this block size from 64 to 128 or 198, this is possible here. So having a bigger block sometimes provides an advantage and sometimes provides a disadvantage also. We'll discuss even these key points also in our next session. What is the advantage of having a bigger block and what is the advantage of having a smaller block like the way. Okay, now look at the simple thing here. If you're having a data file like this, for example 300 MB, some sample data file I'm showing here, word count.txt. I'm having a text file, the size is 300 MB. So the moment you're copying this file to Hadoop, then what happens? Two 128 blocks will be created, and for the leftover 44 MB, a small block will be created. This is what happens in generation 2. On a similar fashion, in generation 1, what happens? So 64 MB like the way, 4 blocks will be created, and for the leftover, the 44 MB block, right? So for this, the 5th block will be created. So Hadoop is not at all simply creating a 128 MB block for a 1 KB file like that. It's not at all wasting any memory here. Please understand that. So based on the requirement only, the block will be created. That's it. So this is the default. It doesn't mean that for just 1 KB file or a 10 MB file, it's simply creating 128 MB or 64 MB like this. Okay, by default it creates a 128 MB. Of course, it depends on the file size that you are providing. So your file is just 1 KB, so 1 KB block only created. That's it. Okay, so this is about blocks. So blocks are nothing but the chunks in the Hadoop file system. Next, We'll understand a few more points here. So big data is as a problem and Hadoop has a solution here. What do you mean by that really? So Hadoop is built and run on a cluster of machines. So just now we are discussing this, right? On the commodity hardware we implemented this. So it's a really good thing, right? And the next thing is it prefers, there is something like a scale out and scale up architecture. So what do you mean by scale out and what do you mean by scale up architecture? Scale out is nothing but adding more machines to the existing system. So for example, today I'm having 4 nodes or 4 machines on my cluster. So based on my requirement, I can add few more machines. Okay, so node 1, node 2, node 3, node 4, or machine 1, machine 2, machine 3 and machine 4. Like the way I'm having 4 machines today. So my cluster size is 4 machines today. So I can increase this. Okay, I can increase this into 10, 20 like the way. So my cluster size can be increased like the way. So this is known as a scale out architecture. And coming to the scale up architecture, just we are increasing the resource capacity. For example, today I'm having a RAM of 64 GB and now I'm increasing that into 128 GB. Like the way my hard disk capacity earlier was 1 terabyte, now I'm increasing that into 2 terabyte. So this particular phenomena is known as a scale up architecture. But Hadoop doesn't recommend you. Hadoop recommends only this scale out architecture. And now Hadoop cluster provides storage and computing. So no need to go anywhere, right? Hadoop provides both the features to you. So you can store the data as well as you can process the data as well. So that too we can do this with a reasonable cost. So Hadoop is not at all demanding you. So in terms of, it's a really a cost affecting factor. As storage is not a big deal here, okay, Hadoop allows us to capture more and more data here. So no need to purge your old data. So in real time you can keep your data without deleting that, because sometimes what happens, when you are working in a different existing RDBMS technologies and all, you'll be getting some notification from your Hadoop, I mean to say some admin people, like you are using a lot of resources, please delete some old data, right? You'll be getting some notifications or mails from your admin people. Whereas coming to this Hadoop, we don't have such issue because storage is not a big deal here. That you need to understand. So with these capabilities, Hadoop really provides a scalable and rich analytics. So what do you mean by scalability here? So there is no bigger size in terms of storage. So 1 terabyte or 1 petabyte. So Hadoop is not at all limiting to you. That's it. Okay. So it's not at all giving any upper bound. That's it. Now coming to the core concepts, computation happens where the data is stored whenever possible. So we'll understand this point and we'll come back to this particular slide later. Look at this. We're talking about the vertical scaling earlier, scale out and scale out architectures, right? So just understand here. For example, this guy is getting 1 GB per day. Okay, so it can accommodate 1 GB, 10 GB and 100 GB. So this guy reached to the maximum, and so he's having some issues with in terms of storage, in terms of memory, in terms of processing also. That's all. So once this guy is reached to the maximum level like this, right, nothing but reaching to the maximum threshold value, this existing system is not at all useful for him. Got it? Because he reached the threshold value in terms of storage, in terms of memory, as well as processing capacity also. So this guy cannot grow his server size more than this. That's it. So this is the major limitation. Now coming to this Hadoop prefers the horizontal scaling. Okay, so what do you mean by that horizontal scaling here? Look at this. So I'm running Hadoop with a multiple single machines here. So this is one machine, this is one machine, and this is one machine, and this is one machine. So all together just gives me a perfect thing here. This is the Hadoop cluster here. So I can put my Hadoop machines into a rack. See here, these are all the racks here. Rack 1, rack 2, rack 3. I'm having multiple racks and I'm keeping my data. So I'm providing storage processing and memory as well. So this is how I'm keeping and maintaining my data using Hadoop. So quite opposite to this, right? So there is no such restriction. So based on my requirement I can add more and more nodes here without any hesitation. So this is nothing but horizontal scaling, or same what we discussed earlier as a scale out architecture. There is no issue with that really. Now we'll understand this point also. This is a common database server architecture, right? For example, you're trying to process some query, like you're having employee data, right? In your database you are having some employee data and you're running a SQL query here, like a select star from employee where location is equal to Bangalore and who is getting more salary than 10,000. So some query you're running. So whenever you're running this query, what happens? Basically your database server have two components, right? One is a processing unit and one is a database server here. So then what happens? Our query, our query from here, it will reach to the SGA, nothing but shareable global area, nothing but RAM, simply a portion of RAM the query is reaching, and from there it will be directed to the database server. So from here what happens? The employee table fetched back to this particular SGA. Now your query will run here, like select star from employee. This query will be run and you're getting the output on your user console here, right? So what I'm talking about here is code to data. So my data will be there and I'm sending my business logic here. Got it? So from my client machine I'm trying to access the server here. So initially my client request is coming to this processing unit or an instance. So from there it's reaching to the database server, or where I'm having my data. So from here the data will be fetched, nothing but the employee table, right? What we queried earlier. So from here you'll be getting the output. This is fine here, but maybe the employee fancies is under the MBs only, right? Even it will never reach to the gigabyte size. But just imagine a scenario where you're having terabytes of data. Can you process your data using like this? Absolutely not, right? Because how we can move this terabytes of data from this location to this and process and getting the result back? So this is really not happening thing. Okay, so if you're having a very less data, this is a good architecture. But if you're having very huge data that you're dealing, so it's really a tough job. Then Hadoop, how it provides? So Hadoop provides a solution in something like code to data, nothing but we are sending our business directly the data where it is located. So for example, all these are my machines: machine 1, machine 2, machine 3 and machine 4, right? Just understand guys this concept. It's very simple to understand, but you need to concentrate here. So look at this, I'm having some data file and the size is 300 MB. So what happens? Initially 128 and the leftover is a 42 MB here. So 3 blocks will be created the moment once you copied the data to Hadoop machines. Suppose you want to process this data, then what we're doing, we are sending the business logic to all these blocks. So B1 will get the logic, B2 will get the logic, and B3 also will get the logic. B1 and B2, B3 are nothing but the blocks. So this file split into multiple blocks, right? So this block is located here, B1 is located here, and B2 is located here, and B3 is located here. So all these blocks will be getting the logic here. So we are not at all moving the data from one end to the other. So this phenomena is known as code to data. So we are sending our business to the data where it is located. So this is how Hadoop provides a solution here. Got it? So this is the issue with the database server architecture and Hadoop, how it provides a solution. Now back to the point. As earlier discussed, Hadoop follows master and slave architecture, and we will discuss that later very deeply. So whenever there is an issue with data nodes, I mean to say the worker nodes or the slave nodes, the master will detect that. okay, and it will take the necessary action, a kind of self-healing mechanism it's having, resilience what we can call. At the same time, whenever you're having some issue with a particular node, for example you're having issue with this particular node, the remaining nodes can work without any problem, so no need to full restart. So for example, you had troubleshooted this node earlier, this is not working fine, so no need to, you know, restart system fully here. At the same time, already we discussed this, data is going to split into multiple blocks like 64 and 128, and there is something like, you know, this is about the storage, but whenever you want to process, there is a concept called map and reduce. So initially map task will run, okay, they will provide the intermediary data or intermediary result, so reducer will come into the picture, then finally you're going to get the result. So once the data is distributed to multiple nodes, what happens here, you can see this, so the data is initially spread into multiple blocks, right? Sorry, the blocks will be distributed to multiple nodes, right? And we are sending the logic here. So in the logic, what happens, initially the map task will run, like here map task 1, map task 2 and map task 3. So 3 map tasks will run in parallel and they provide the intermediary result. So once all mappers has run successfully the logic, then the intermediary result will be processed by reducer logic. So what do you mean by mapper, what do you mean by reducer, how they will process, okay, what do you mean by that intermediate result, those things will be answered in our next session. But limit to the discussion, just understand, once data is distributed like this, we are sending the logic. So what kind of logic we are sending? So initially the mapper logic. So mapper 1, mapper 2 and mapper 3, those guys are working in parallel and providing the intermediary results to you. So once that is with you, you are starting a reducer. So by reducer you'll be getting the final result. So how it happens, I will explain with a simple example in my next session, so that you can understand what you mean by mapper, reducer, and what you mean by that intermediary result and everything here, right? And these things also I explained that time only, what you mean by this master program, how it allocates the worker nodes such as a map task. So there is a process called a job tracker, so which allocates the work. So job tracker and task tracker, so all this name node, data node, all these components we'll discuss in architecture part, nothing but in our next session, right? So back to the discussion, we'll understand one more concept here, rack awareness and replication. So already I mentioned, right, replication. What do you mean by replication? So once we are copying our data from local file system to Hadoop, okay, initially blocks will be created and those blocks will be replicated to multiple nodes. Why? Because we cannot trust on this particular commodity hardware, right? So that's the reason why we are replicating. So how are you going to replicate this? So for that, it follows some rack awareness concept here. For example, look at this is my rack 1, rack 2 and rack 3. So the guys who are not having any idea of the rack, just visit this slide. So this is the rack 1 and this is the rack 2 and rack 3, and here you can see the machines, right? So similarly, I'm having 3 racks here, rack 1, rack 2 and rack 3, and I'm having some 12 nodes or machines. It's up to you how you're going to call. So node 1, node 2, node 3, node 4, like the way I'm having 4 nodes in rack 1, 4 nodes in rack 2 and 4 nodes in rack 3. So the moment we copied the data, how the data has to be distributed, okay? For example, this is your input file and each 64 MB, like the way initial split has happened, right? So once the initial split has happened, that has to distribute it to multiple machines like node A, node B, for example node C, like this way. So how to distribute the replicants here? Because you cannot keep all the replicants on the same node or same rack, right? Why? Because why I can't keep all my replicants on the same rack? What happens if this rack is gone? That's it, I'm losing my data. If I'm keeping all my data here itself. So that's the reason what I had to do. I had to place these particular replicants in an intelligent manner. So I had to distribute these file replicants to different machines and different racks. This is what exactly I had to do. And what is the principle for this? So if you're considering your default replication factor is 3 here, you have to place the first replicant on the local rack, second replicant on the local rack but on a different machine, so third replicant on totally a different rack. So we'll simplify the discussion. At any given time, you cannot have all your 3 replicants on the same rack. Okay, so you're having a file, your employee file, for example, or sample.txt, whatever it may be, and it is split into multiple blocks here, right? And you're having a rack awareness concept also, so you're having a very big distribution now. So you cannot place your all replicants on the same rack and on the same machines also. Look at this. For example, I'm having a color coding thing here sorry, like a block 1, block 2 and block 3. So in rack 3 on machine number 12, I'm having a one replicant here, and 2 more replicants of this block 2 are placed in rack 1, that too on a different machine, not on the same machine, right? So what this principle says, really, at any given time on a single rack you can have a maximum of 2 replicants, but that too on a different machines. So you cannot have these 2 replicants on the same machine. So N2 cannot accommodate these 2 replicants as they belongs to the same, but you can accommodate a different blocks. So this is possible. You can accommodate a different blocks, different replicants you can accommodate, but same thing you cannot keep here. So this block 3, okay, this block 3 green color, so you cannot have 3 replicants on the same rack. You can have a maximum of 2 replicants on the same rack but on a different machine. So this is possible. So this principle is known as rack awareness concept. Now there is one more important concept called intra-rack and inter-rack communication. Suppose if you want to read the file distributed to multiple machines, right, or multiple nodes, then how are you going to read this? So look at here. So I'm having 3 racks and 12 machines total. So here you can see the switch concept here. So there is some principle called intra-rack and inter-rack communication. So what does it mean by intra-rack? So this communication between this N1 to this N2 is something like intra-rack. So from here N1, N2, if you want to read the blocks N1 and N2, so this is purely a intra-rack communication. But if you want to read from here, okay, so if you want to read, for example, this particular blue color, nothing but block 1 if you want to read. So if you want to read this block via switch, you have to connect to the next track and you have to read this. So this particular phenomena is known as inter-rack communication. Okay, so the blocks which are under the same rack is nothing but the intra-rack, and the blocks which are under the different machines on a different rack, you have to go with a inter-rack communication. So this is what exactly I have mentioned here. So always this particular inter-rack communication is a bit expensive because it needs more resources, network, RAM and everything it requires. Got it? So that's the reason I have mentioned here. So this is a bit expensive kind of thing here. Always expensive, this inter-rack communication, because it no need to any switch this inter-rack communication needs the switching process, and it has to read the data from a different racks that are within different machines. Alright, so this principle is known as inter-rack. And if you want to read these blocks, this particular block, this is a block 3 and green is a block 2 here. So if you want to read this block 2 and block 1 from this rack, okay, both are existing on the same rack, so this is something like known as intra-rack communication. So right, that's all guys for this session. In my coming session I'll be explaining the core components of generation 1 okay, and followed by we'll be understanding the core concepts of generation 2 also later. Okay, so these are the core components. Like we'll be discussing in tomorrow's session what you mean by HDFS and what you mean by MapReduce, because earlier I said, right, Hadoop follows master and slave architecture. So what's a master and what is a slave? So we'll understand all those things, right? Right then, I'll be ending the show here. See you in next session. Thank you.